from San Jose, Costa Rica, the headquarters of the ICA, the second day of the Digital Agriculture Week with a very busy agenda for the next three and a half hours. And we invite you to follow in detail each one of the interventions. And without further ado, and after this greeting, I give the floor to Viviana Palmieri, who will facilitate the block, this following block. Thank you, Federico, and good afternoon to everyone. It's a pleasure having you here and to continue with the Digital Agriculture Week, and today with a focus in the more academic and research part of this, and what does digital transformation mean in this regard. And first of all, we have a conference on digital transformation of agriculture benefits and possible risks from Lawrence Kurtz, who is a professor in the Technology and Innovation Group of the University of Groningen, Holland, and a friend of ICA. Please go ahead, Lawrence, with your presentation. Thank you very much, Federico and Diana. It's a pleasure to have you. I will share my screen. Let's see where I have this presentation. Can you see my presentation? I guess you can. Yes, perfect. Very well. So it's a pleasure to be this morning, afternoon, or evening with all of you there in Latin America and, of course, in North America. And I will speak about digital and positive digital transformation for production, the environment, and for people. And I'm very thankful to be part of this Digital Agriculture Week. It's a very interesting program, and I'm also I'm looking forward to see who's going to win in the startups. And what will I speak about? Well, it's going to be a brief presentation, parts of these presentation. I also shared in an event of Innovagro Network, but here I'll focus much more in the benefits and possible risks of digital agriculture transformation, how to promote the dynamic digital transformation, inclusive, and as the last point, roles and collaborations necessary to produce this positive digital transformation. And as Viviana said, from science, there's been an increase quite significant in latter years from social sciences, humanities, in positive aspects as well as negative aspects of digital agriculture. And literature is very much focused in the technological, very much focused in possibilities and options that exist. But recently, and I'm talking about the latest 5 to 10 years, there's also an agenda more critical from the science standpoint. And you can see this in these articles. We reviewed the literature where we verified this critical literature. But of course, it's not only enough to criticize, we have to give constructive contributions. And you can see increasingly that from social sciences, there are methodologies presented to be able to perform that inclusive innovation. And as you can all see, and without a doubt, was presented yesterday and will be repeated in coming days. There's Agriculture 4.0, and digital agriculture is part of it, and it's growing in Latin America. In all the different links of this chain, you can see startups, applications, technologies. Different countries are investing strongly. Investors throughout the world are investing in Agriculture 4.0 in Latin America. And according to what I've read lately, it's one of the continents with the highest growth in latter years in this matter. And one example is a digital extension or outreach, to have apps that can provide market information with which you can diagnose quality of soil, where you can diagnose diseases and also receive solutions, growing solutions. And it's also available for all types of producers, not only for large producers, but increasingly for smallholders or small producers. And this is only an example. You'll see much more in this digital agriculture week of all the other options that are being developed as we speak. And it's interesting that Agriculture 4.0 has various definitions. In some countries, it's defined as precision agriculture. In other countries, it's seen as hyper-connected agriculture, not only precision agriculture, but also connections with the chain through blockchain and including robotics. But if it's called 4.0 or 5.0, it is a fact that in all these technological environments, there's developments throughout the world and also in Latin America. And why is this presentation is not part of the gap? And why is it not complete novelty? Because there are already many ideas on the benefits and possible risks of digital transformation. There are various reports from different organizations, ECLAC, from ICA, that considered that it's not only pretty and beneficial, but you must also focus on the possible risks and disadvantages of digital agriculture or agriculture 4.0, 5.0. So some see it as utopic. Uh, Others have an image of the producer behind a desk managing the whole farm, that no longer has to go out and see the animals or the plants. Some see it as an ideal situation. For others, it is the terminator of agriculture dystopia. And these are extreme views, I believe. I believe we must find a middle ground. Of course, there are some good things, but also bad things. But we must have a reasonable discussion on how we can develop this agriculture 4.0, 5.0 for it to be a benefit to different farmers, to also for it to have benefit for the environment, to have a human scale benefit. We could say it's very fun to be a farmer if you're behind the screen all day, but I think not many farmers are farmers to do that. Of course, it's important for work to be pleasant, not as wearing. Many do agriculture because they like connection with nature. And those who are more critical clearly have written in these reports their concerns. They say that digital agriculture 4.0, 5.0 is a straining of an extractivist model that will not affect nature, that will not promote circularity or regenerative agriculture as mono crops. And the most critical say that there will be more concentration of power in chains, that some big actors will control the whole chain, and there's very little to choose from. And at the end, it won't benefit anyone. It won't benefit producers nor consumers. And these are the most critical, as I said. Some say there could be effects on social exclusion. These technologies have a cost. Those who cannot have the efficiency, cannot access, compared to those who can buy these technologies, those who can't might be excluded, or the ones who don't have digital literacy will not be able to be part of agriculture 4.0, 5.0. And as I mentioned, there's environmental effects also, possibly. These technologies require energy, require electricity, require data centers. And all of these centers require use energy that is produced somehow. If it's not by sustainable sources, won't be sustainable. There are also other minerals required, sometimes very hard to get, and this also require uh, will not only be beneficial for the environment. I spoke about cultural and what will agriculture do to field culture. I spoke about this. I spoke about social exclusion. We have the digital gap where it's not accessible for everyone. So it's important to not only see the negative part, we must make a balance. And this is an example of robotics. My friend David Rouse from England, and he says that autonomous agriculture with robots in the economical part can reduce labor costs or supplies cost. And some farms that are currently not sustainable can be maintained because they lower the labor cost. But the negative part is that these are not accessible to everyone. It requires high amounts of capital. There could be dependencies of some companies for repairs, for spare parts, especially when technology is protected by patents, licenses, and there's no right to repair. So another scope, and I won't read the whole thing, but in all these different scopes, there's pros and cons. And this is also the case in health. Robotics can do perform dangerous, hazardous jobs and harvesting, and this can improve people's health if they work with robots or possibly replaced for certain jobs by robots. But there's also danger when the robot goes crazy, no one can stop it. And for that reason, there's currently many controls by regulators and to use robots that are 100% safe to prevent this from happening, for robots to be loose and no one can stop them. Without a doubt, you've seen movies, terror movies, where that happens, and we don't want any of these terror movies in the field. We don't want robots to go wild. So there are pros and cons, and it's very important to to make a good balance and see the risk, but also the positive side. Some only see the negative things, others just see the positive things. We must carry out this type of analysis. And this is happening increasingly in Latin America to have an inclusive digital transformation that is good, that is positive. And for this, there's agriculture, digital agriculture in action, and also digital inclusion is also considering this topic. And to do this, this requires methodologies, it requires certain different approach. And one possible approach is responsible innovation. And this approach is about forecasting what could happen, also to anticipate who this technology can affect and include those in the development process and reflect on what we can adjust and adapt technologies to not produce so many negative effects, and as much as possible for these to be positive. So this methodology is to understand the trade-offs, and which sometimes happens, especially with startups, with the technological design programs, where there's a techno positivism, where everything technological is nice or pretty, and sometimes they forget to inquire the different aspects. And it's also very important in this process to decide who we're creating this technology for and how can we create diversity of digital technologies, agriculture 4.0, which has different public to not make it one solution for all and make it and have more initiatives on diversity by design and develop technologies that work for smallholder farming. And to then include all effects, we must see the different domains or different areas. And one example of a tool that can be applied is this tool for to see agriculture 4.0 as a social, cyber, physical systems where there are physical elements, fields, farms, infrastructure, supplies that are used. This domain interacts with the cyber domain, ICT, technology, AI, robotics, but there's also a social component. So we must see all these different interactions because sometimes these can have a very positive effect, boosting increased productivity, but sometimes it could reduce the connection with the field. It could reduce people's capacity, and farming becomes too dependent on certain technology, and this could pose some risks. For instance, if there's hacking or a cyber attack. So if we look at all these different interactions, we can have a more complete view of which are the positive and negative aspects. And Mario Herrero also uh, contributed with the Sustainable Development Goals. And the question is, what effects do these technologies have on certain goals? Do they help? Do they counteract these goals? So all these analyses can be used, and these are available. But the important thing is for those who develop these technologies to apply these methodologies and to make it part of the development process. So this helps create proper technology, but also to think of what needs to be changed in the environment for these technologies to be good and to lower risk. For instance, if you find with this analysis that digital capacities must be created for this, create a framework with the industry to work with these technologies in a safe, healthy manner. And you might also say, well, technology uh, also has to be for small producers and have mini robotics, for instance. So we can look at how to improve technology for different uses, but also how to adapt the environment for it to be favorable for the different types of producers. And also very important to consider that it doesn't need to be necessarily high tech. The most successful ones seem to be low tech or everyday use technologies. For instance, this is a news about a young girl in Colombia who created a platform for market information with WhatsApp. So it's a simple, cheap technology, and sometimes it's better to work with that than creating a new app that at the end will not be used and that will go broke in a few years. So as I mentioned, we must prepare the users, the producers also. Producers must have the readiness, must be prepared, but we must also prepare the advisors to work with these technologies, train the producers to use this technology, and and especially because this is receiving great attention from the organizations that work in outreach, for instance. So or extension. So there's a level of readiness in many environments. Many times the start of the focus on technology readiness for the technology to be ready to go to market. But we must work also on the market to be ready to have environment of easy repairs and also in robotics. to have reasonable pricing and also legal framework that accepts robots, and also for producers to accept it, for it to not go against their values or their culture as producers or their identity, also very well integrated with the organizations. And farms, for instance, farm is an organization for them to understand how to work with robotics. Not enough to just throw it out there in the market, but also prepare the market, and the environment is very important. So there are various levels of preparation. So what are the implications for innovation systems with a inclusive digitalization views and innovation systems? At the end, they are multi-actor, public-private partnerships, adaptable. This has to be have all these conditions. And here you see some figures of the implementation of a robotic milking. And here it requires many things, create legislation, train the producers, have industry standards, manage change management, adapt technologies that go to a new environment. And all this is not only done by the private sector, but there's also a public role with the organization. So, in fact, all this work has to be coordinated, and many times it takes many years to be able to introduce this technology successfully. The good thing is that this is being thought about. For instance, ICA thought about this, and it already distinguishes different roles for various actors. And ECLAC also has a state of the art in the different countries, and they say this has to be well organized. And I believe that for this, the system managers or intermediaries that connect all these actors in the different stages of development can facilitate this. But what must be more developed is possibly take all these analysis, methodologies, pros and cons, inclusive innovation, and responsible. And that's possibly an area that must be strengthened by the countries in Latin America and also in North America. When you see the literature on responsible innovation, it's done a lot in Europe, New Zealand, Australia, but there's not as much literature about these processes in the US or in Latin America. It might be there. If not, it would be good to further develop that. I think that to see what has been done so far could be very useful to use good experiences. And as I said, these methodologies, good design, responsible innovation are very important to reach proper environments and technologies. And for this, a government role uh, is necessary to guide, simulate, regulate, or even stop digital transformation. Sometimes these developments are too fast or too disruptive, and sometimes it causes too much damage. So sometimes it's best to prevent than to repair a damage. Sometimes it has to be slowed down, pause, and say, how can we in fact do this in a way that is responsible and adequate? So thank you very much. It was a pleasure to present. And if there are any questions, I'm happy to entertain. Thank you very much, Lawrence. Very interesting. All you said, especially all the considerations that would be taken into account for this inclusive digital transformation. You mentioned because of time constraints, we'll only allow two questions. If there's any question from the public, either in the Zoom platform or anyone here in the room, does anyone have a question for Lawrence? Very good presentation, Lawrence. And I wanted to ask you something. If you can shed some light on your views on comparing digitalization, agro between the different continents, or at least compare Latin America or within Latin America, what countries you see more advanced, and how would you compare this with Europe or the US or other sectors where you have more experience? That's a big question. I don't know if I have an answer for that. I believe that in Latin America, there's a very fast development currently, and in some areas, you see very many successful startups, platforms, supplies, information sharing. I think in that area, Latin America is quite advanced. I haven't seen a lot, and I could be wrong, but I haven't seen a lot in robotics. Not in Europe, in New Zealand, and Australia. It's implemented at very high scale, but there's a lot of implementation, many programs. There's a huge public investment. For instance, in Holland, I think it was 600 million euros for 10 years to develop that further. And I think that's a sector in Latin America that could be potentiated to end and use the good and bad experiences of the countries that are more advanced. However, there's a much more potential for small producers, but also for large producers because there is scalability in Latin America for that type of investment in robotics, for instance. So this is a very, very high level, but there is great dynamic in Latin America at this moment.
Nicolas? Thank you, Nicolas. And with this part, we close the questions and answers. Unfortunately, we do not have enough time. Good afternoon, Lawrence. My name is Nicolas Antinelli. I am part of Sheward, a company using robotic and artificial intelligence to crops. And you made a comparison between Europe and Latin America. And one of the areas you mentioned is that Europe is more advanced is in robotic. What are the major arguments Europe is in to invest in this line considered as key, while in other continents they do not receive the same attention? Well, they mainly invest in robotic because of work quality in order to reduce the dirty jobs or serious or dangerous jobs. And also because of cost and availability. For example, in the sector of fruits and vegetables in the Netherlands, there is a serious problem with the labor. So to automate this is impossible. So it is impossible to continue being competitive and to keep people for harvesting times. Those are also options and elections. In Latin America, there is a viable option that people work in agriculture, and very often it is quite skilled labor. So sometimes we believe that it is easy to harvest, but it is not so. So what would be the reason to invest in robotic? Instead of providing better conditions for workers. So it is important to make a contextual analysis to see what is the need for robotics and what type of robotic. In Europe, mainly, it is a lack of labor, and that's why they are using a lot of robotics. Thank you. Now, we will have Michael Kramer participation. He is a Nobel Prize in Economy and Professor in Economics Public Policy of the Chicago University. And he will give us a short presentation through a video.
Thank you for the invitation. Digital agriculture has huge potential to improve people's lives, and I'm delighted that there are social entrepreneurs like you working on this. I also applaud ECO's work on this area. I'll briefly discuss some thoughts about the potential of digital agriculture. In high-income countries, where agricultural productivity is high, tractors often use GPS devices to optimally dose inputs at extremely fine levels. Precision farming. In lower income countries, advice is usually given at the district level or an even higher level of aggregation. This means that diffusion of innovative technologies or approaches in low and middle income countries is often slow, limiting growth in agricultural productivity. However, mobile phones are widespread in low and middle income countries, even rural areas. Smartphones are themselves widely available. This creates the potential for low-cost, customizable, timely information provision. Text messages are extremely cheap to send, but even voice is not very expensive. While extension workers can only be in one place at a time, messages can be sent to millions of farmers during planting periods, pest outbreaks, adverse weather events, whenever they're most relevant. Recommendations can be customized to account for local soil characteristics, weather conditions, etc. My colleagues and I combined the existing evidence, and we estimated that digital agriculture services increased yields by 4% on average and increased adoption of recommended practices by 22%. That may sound modest, but let me note that that's with basic mobile-based systems, not even smartphones. And there are newer technologies that I think will offer a lot of opportunity for future improvement. Even those 4% gains represent a 10-to-1 benefit relative to the cost. As technologies advance, there will be opportunities to improve these systems. Farmers have a lot of information themselves that can be useful to others. Well-functioning agricultural extension systems could use digital tools to collect this information in a systematic way and feed it back into the system. Mobile technology could be used to improve input and output markets, for instance, by providing price information or linking farmers directly with customers, suppliers, or traders. Often farmers in developing countries don't have access to good weather forecasting, which could help them decide when to plant or when to harvest. Mobile extension would be a natural way to deliver more accurate local weather forecasts directly to farmers. Another potential use case is to support and monitor extension workers. I mentioned before that the performance of extension workers is often very weak. I don't want to imply that in-person extension doesn't play an important role, however. Digital technology can be used to improve the performance of in-person extension workers, and in some cases as part of management plans. Digital technology could improve the quality of information available to extension workers when they visit farmers in person. For instance, smartphones and tablets could provide video tutorials and camera-based diagnosis and decision support tools. It's projected that by 2025, 75% of mobile subscribers, even in sub-Saharan Africa, will be using smartphones. So many of these innovations could be delivered directly to farmers as well. Finally, I should mention that there's been a lot of enthusiasm about using mobile phones to provide smallholder farmers with loans and social insurance products. Overall, digital agriculture is already a highly cost-effective way to increase yields and has the potential to be even more impactful as technology advances. Thanks very much.
Muchas gracias por la presentación.
Thank you for your video presentation. Now, Luis Adrián Salazar Soares, former Minister of Science and Technology and Communications in Costa Rica, will talk about the new schemes of science and technology in the digital scenario. Go ahead, Luis Adrián, floor is yours. Welcome. Hello, good afternoon. My special appreciation to ICA for this invitation and this opportunity. Greetings to Manuel Otero for developing these presentations and these weeks of ongoing learning generation. When I have talked to Manuel and his team, Erika, there's always an element which is vital in order to generate the progress in agriculture. And that is how to enhance skills and capacities of people for them to take disruptive technologies in the process of agriculture generation. Very often, and we see this increasingly, regressive displacement of many young people that have his or her origin in agriculture but feel left behind because of the digitalization processes, capacity building, and so on. And they move to other working areas, to other knowledge areas, and being able to generate, to find the matching point has been missed. Matching point between technology, agriculture development, and the inclusion on a digitalized world. So when many young people start listening about artificial intelligence, about IoT, about cloud computing, and they even see that many of their colleagues are migrating to the cities to go into engineering aspects or topics related to telecommunications, robotics, and so on, they feel they are being left behind. So at the country level, we generate a space where we are always proactive and the split in order to generate equal opportunities at the scientific and technological level, access to technology, access to telecommunications, but the reality is not so. So we enter into a dilemma where we need to train, to technically train new generations and the same way to avoid, to prevent a digital gap that will imply an economic gap and a social gap. So certainly the big challenge that exists nowadays is to be able to put on a sufficiently articulated manner the different efforts that are made from the academia, the private companies, and the public sector. In many countries in Latin America, there are, and let me see, in many countries in the world, there are projects and there are initiatives that are directed to the creation of technology or to the use of technology, even with important names such as disruptive technologies for development of agriculture and livestock, the use of drones, the use of nanotechnology. However, there are many efforts made, but sometimes the concatenation of these efforts and the articulation for a good use to the resources that very often is not enough, and to get the best benefit possible makes the model, turns the model into something complex. So it seems that we have the assessment, we know what are the different weaknesses we have, well, we need to address to be more evolutive and more sophisticated with regard to the capacities, technical and cognitive capacities to take agriculture to the process of digital transformation. But at the time of running all this, it's not so simple. Sometimes conceptually we have the processes, but it is not so easy, so feasible to see results. That is why I believe that such an event, like the event that we have today, opens a possibility for us. And this event is not limited just to the knowledge generation that we're going to be able to share this week, to be able to generate experiences and to exchange good practices, but to generate an action plan. And to generate an action plan that implies in the middle, in the short and very short and long-term results, results that will let us to create capacities. I mean, to have this low hanging fruit, this capacity is for people to see that that's true. In agriculture, with artificial intelligence systems, with RPA systems, it is possible to empower all this and all this with an important feature. Nowadays, and because so you are more expert. I'm an engineer in computer systems, and you are experts in the subject matter. So you know that we have a serious and complex situation regarding the capacity of provision of different types of food because of the war between Russia and Ukraine. And we are not only giving the opportunity to a vulnerable group, but to a group with needs, a group but is the group that gives us life. It is the group that led us to have food. It is the group that allowed the reduced hunger in the world. A vital element to be productive, to create and generate the policies that led us to have an appropriate growth. And what is the challenge? The challenge is that we can generate an action plan, a small mapping of what is it that we can share, each one of us, that can reach the different instances in the different countries to start generating credibility, to generate this initiative on behalf of those people that are seeing things quite difficult. Agricultural groups, we have some agricultural groups that are of subsistency, there are more corporate. However, at the end of the day, there are two elements that are vital. One, the capacity of productive improvement, knowledge extension, cost reduction, and maximization of profits. So when we see that we are on something where there is an offer that could be limited with a demand that does not satisfy the offer, and but there is talent, and we have the necessary tools to generate an action plan in a concrete manner and to articulate through the many entities that exist in order to provide results for people to start believing, for us to realize that there are options of the use of the disruptive technologies, both at the high production capacity level as subsistence production, that the use of technology makes the processes more efficient. But besides that, it also allows, enables the young people to support their parents and grandparents by cultivating the land for all of us to push together instead of seeing the paradigm that the older people need to give a hand to the younger people. No, the younger people with the technological capacities can can help those, the elderly or those who have had a more difficult relationship with the land to transform all of this in a productive cycle, efficient with the appropriate use of resources, but also that we can solve the demands that the agriculture imposes us on a daily basis. There's a case that I command along with Manuel Otero, and it's the lab of the Fab Lab, the manufacturing lab that exists in Ica in Coronado. I am from Costa Rica, and there we give some resources, we put some computers, some IoT elements, and we started training, providing training. So to giving the possibility for development uh, in order to concatenate these technologies, these converging technologies with the capacities of people, and particularly by developing skills in girls and women in the scientific and technological field. If we see And we can turn all this into a reality if we can make the ministers of agriculture in some countries that the responsible parties of academic centers, of research centers can provide us this possibility to join talent and agricultural extension and the capacity of the disruptive technologies. I believe we can generate a pretty good generation of a productive cycle, quite positive. And what do we need to do so? We need, number one, will. Number two, knowledge. Number three, minimum resources, letting us to establish an action line. And number four, action. Beyond all this, we have to do this all together. Sometimes in America, we tend to forget that as we have potentialities and as we have vulnerabilities, we have the possibility to work in conjunction. And when we are capable to work in conjunction, we are capable to create and to provide results. And this scarcity of potential resources for macro projects, we can be synthesized with small little efforts from the little resources that each one of us from different institutions, different countries may have, that we can sum to work in conjunction for all of us to progress more and to start turning all this because the digital transformation process at the state level are more and more priority and more important, and to turn all this into a public policy, into a real government decision. When something is a priority for the government, is related to resources. I have not seen a single administration with priorities without resources. So when we, as a priority, we try to include the substantial inclusion of technology and agricultural process for productive improvement, for the argument for an increase of the capacity of development of this talent that exists, because it is a lie that the talent is in the hands of those who are in one place or another geographically. Talent is innate that each one of us has, and this individual talent must be empowered through collective education to turn it into knowledge. Or do we lose things when this individual talent cannot find the key of opportunity to have access to this collective education supported in digital technologies? So with this short intervention that I have, 15 minutes presentation, I would like to leave you with three topics on the table. Number one, we can. Number two, we must. And number three, we can only do this if we work in conjunction. And I believe that these elements will make possible that this type of event become an exchange of ideas to generate actions, to generate activities, concrete activities, letting us to measure results on time. So I cannot be more than thankful with this invitation you have made to me today to share with you this time where I believe we can draw very good conclusions in order to have better opportunities and more opportunities for all of us, all of our colleagues. Thank you very much. Thank you to you for the reflections on how we must address all this. Now, let me introduce you to a team of the New Mexico State University. They will talk about the vision and actions from this university. I said team because I know you are on the screen, and we see Mario Allegri and Manoj Shukla are connected. We have Edgar, but I do not know exactly in what order you organize to share with us in 50 minutes your presentation. Thank you very much.
Thank you very much. Can you hear me?
Yes.
Okay. All right. So thank you very much. Once again, welcome to the Digital Agriculture Week organized by the IACA. As the last speaker said, my name is Manoj Shukla. I'm a professor of soil physics at New Mexico State University. And we have some excellent slate of speakers here with me from New Mexico State University. Let me just briefly show them, Dr. Lara Pertikov, Mario Allegri, of course, you know him. And on my left is Mahdi
Actions.
yeah, Zariani.
Yes.
And the online, we have Dr. Bailey, Derek Bailey is there. And I also see Don Edgar on this. So yeah, thanks for joining today. So, as so many speakers said today that digital agriculture is essentially the use of the advanced technology for agriculture or the livestock management. And the overall objective is to improve all the efficiencies as much as possible. And of course, the ultimate goal of agriculture systems are always increasing the production. Digital agriculture, as the speaker from Wageningen showed us, utilizes various communication networks, various sensors, UASs, artificial intelligence, robots, drones, and other advanced systems to process and interpret the data. And the ultimate objective is to present the data to the growers and farmers in a way so that they can easily use it. And so similar efforts are also ongoing here at New Mexico State University, where we have 12 science centers, and one of them, Linebacker Science Center, which is located here in Las Cruces. We are trying to make that a center of excellence for digital agriculture. So last 2 years, we are working with that center, trying to use the Internet of Things and LoRa systems and instrumenting several of our farms. And the ultimate objective is to increase the water use efficiency. Because those of you who know New Mexico, you know that unlike Costa Rica, we hardly get rainfall here. Our precipitation is less than 230 millimeters. And therefore, what is happening is with the continued drought, we have very little fresh water available for irrigation. And therefore, there is a lot of pressure on the groundwater resources. And therefore, improving the water use efficiency has become very important. In addition to that, there are different types of disease and pest pressures on the crop. So once we are using this DI technology, essentially we can handle many different things at the same time. So we are doing a lot of work using the drones. We are also using the robots, and I thank the previous speaker for bringing out that point. And we'll try to make sure that our robots stay on the farm and do not stray. And so we are using the robots. And I think when we were in IACA this April, I gave a presentation and showed a video of the drone, how it can operate and actually collect the data of the over the canopy leaf temperature, then also measure the soil moisture content. It can also do the spade readings, which can be interpreted as the chlorophyll content. And it can also collect the pictures from different angles, and those pictures can be processed to detect the diseases or the plant stress. So that is, so far we are very successful with that part of the data. Of course, it is still processing of the data to make sure whether there is a disease or there is only a abiotic stress that is causing the yellowing of the leaves or any other stress symptoms. We are still working on those things to refine it. The other thing that we are working is to bring down the cost so that those can be utilized by the growers in the area also. And hopefully we will have, in collaboration with IACA, a model robot which will be eventually placed at the IECA Center in San Jose, so that we can spread that technology to many other parts of this the Americas. So I see that Dr. Derek Bailey is here, and livestock is a very important component of digital ag here at New Mexico State University. So Derek, the floor is yours for next 5 minutes.
Great, thanks, Manoj, and thanks, Aika. I really appreciate the opportunity to visit with you. As in New Mexico, it is, as Manoj said, it's very dry, so we have to have very large, extensive pastures, as you see like here in my background. The productivity is low, so that takes a lot of land to support livestock, especially cattle. So they're hard, since they're on such large things, they're hard to monitor. It's just difficult to see them regularly. So it's tough to manage, to monitor, with human observations, to monitor the health, welfare, and productivity of the livestock. And also difficult to use all available forage, because just sometimes animals are reluctant to travel much over 3 kilometers from water and often avoid steep slopes. So these things we have been tracking. I've been tracking in my research cattle since 1998. But the exciting new thing about digital agriculture is that it is becoming much more feasible to look at this in real time, to be able to see that and be able to have technologies that you can use your smartphone to see where your livestock are and have some idea of their behavior, whether it's a deviation from normal behavior. So we use a combination of GPS tracking and accelerometers, and both are available either near or real time from various vendors. We test a lot of various vendors for their equipment to real things. We are not, personally, I'm not very interested in developing my own technologies. I think it's difficult to get those types of technologies off the ground and started and make them commercially viable. And I think the university just is not really in the business to support the ranchers and livestock producers to be able to use that technology. So we're working with vendors and developing algorithms to better utilize that, so that eventually can be used by the farmer and the rancher. The whole idea is that we're really looking for normal patterns of behavior, and we're looking for changes in that. When there's change in behavior, there's usually a problem with the livestock. If they're not active in the morning when they normally graze, they may be ill. If they separate from the herd, they may be lambing or calving. If they're more, and so you can look at the length of it. If their grazing time is increased, they may be running out of feed, or if they travel further, they may be running out of feed. So those things are all can be managed from that. And so the secret is to be able to develop new algorithms and software and technology to get that to the hand, so it could be more useful in a user-friendly format. So we're testing those things, and we're working hard to do that. We're working with NMSU's computer science thing, and with all the members of the team here today, with Lara Perdoco and others, to think about utilizing artificial intelligence to help detect these types of changes and make it more useful and good things. So we are very excited about the potential for this. And again, the price is very expensive, but it's going down. And that's facilitated by the supply chain is a real issue around the world. And so there's a lot of new technologies designed to be able to track and monitor shipping containers and trucks as they move across the country and up and down the roads to deliver the product. So the same equipment that is used to measure and monitor shipping containers can also be used to monitor livestock. And so that's really allowed the technology to evolve and make real time a possibility and make it feasible, and likely to make it much more affordable in the near future. So thank you.
Thanks, Derek. That's really useful. Those of you who know New Mexico also know that chili is one of our specialty crops, and one of the major challenges for chili is to really find out a harvester which can harvest the chili, because we have very severe labor shortage here. So I'm giving floor to Dr. Mahdi Jariani, because he is the one who is an expert on the robotics, and he is working on some of those harvest of chili related issues. So, Nati.
Thank you, Manoj. Appreciate for inviting me and giving this opportunity to talk about my research. As Manoj mentioned, my background is in mechanical engineering and working in the robotic systems. One of the areas that we are focusing recently is in agriculture. I think that one of the major issues that we see in the chili pepper harvesting at New Mexico is mainly related to the labor shortage, and it was an interest from the Chili Pepper Association to have some research and work in the area of trying to have some human-like harvesting, because mechanized machines have been tested. But the need for the fruit to be detached and be detached from the pedestal and things like that, which is one of the issues that usually the mechanized machine cannot provide, was to go back and have a robotic system could mimic the human harvester. So we decided to give it a shot, and we started working on this area by using the robotic arms and the mobile manipulators in order to be able to do this human-like harvesting. So one of the current research that we're doing right now is to use these robotic arms and some of the specialized grippers in order to be able to perform the harvesting very similar to the human. I have collaborators in the College of Engineering who is helping with the fruit identification. One of the aspects of the harvesting is that the machine be able to detect the fruit, especially we are interested in the green chili pepper, and the fruit is green, the leaves are green. So it's very challenging for the machines to be able to detect fruit. So I have collaborators working with us in order to be able to detect fruits, and then the robots be able to plan in order to be able to reach to the fruits and harvest them. We're still in the feasibility phase of this project. We're trying to improve the motion planning, the performance of the robot from the perspective of the successful harvesting. I mean, that most of the robotic harvesters so far, you can see all around the world, mainly works in the greenhouses. It's a very controlled environment when the fruits and the vegetables are mainly exposed. What we're trying to do here is to make sure that they can have a robotic system which working outdoor in the field, which is very challenging. There are a lot of variables that we need to consider. And I think that we're on the track. So we have a very good result so far, and we're trying to improve it. And there's a great opportunity and potential for using the robotic systems for harvesting in future, and hopefully help the New Mexico to bring back these special crops.
Thanks, Dr. Jariani. New Mexico State University is a land-grant university with teaching, research, extension, and outreach are the main missions. And so the digital agriculture program here in the College of ACES, New Mexico State University, also involves all of these three functions. And the education component is led by Dr. Don Edgar. So Dr. Edgar, floor is yours for 2 to 3 minutes.
Okay, I'll try to make it brief. Thank you for this opportunity. I think as the previous presenters had talked about, especially before we got on, and I was excited to hear that about the social aspect and also the extension aspect. That's one of the areas where we're really trying to, and I kind of titled this, distill down what we do. We're all experts. We know how to use technology. We understand technology. But I think all of us have phones and we understand how to use it, but I don't think we understand all the aspects of it. So when we expect farmers, producers no matter where they are, if they're in the US, if they're in South America, if we expect them to understand and implement digital technology, we really have to be that resource to take what they need. And as Manoj had said earlier about distilling down that data, how do we give it to them in a format that they can understand? We're really not giving them the tools to be successful in it. And one of the areas that I'm really trying to work on is taking a lot of technologies that we utilize and then figuring out how to get that information to producers' hands. And I think extension is one of those areas, workshops, anything that we can do to show them what they can do with it, but also how it can be valuable for them. Because if we don't get their buy-in into this technology, they're never going to adopt it. They're never going to utilize it. And it's not going to be anything impactful for them. It'll be like a cell phone that doesn't have any service. They have it, but what do they do with it? And so again, I think one of the major concepts that we're trying to work in across, whether that be through a digital agriculture degree, whether it be understanding technologies and how they can be valuable for people, is how do we take those key components and explain it to them in a way that they can see the value in it and then adopt it. Okay, thanks.
Thanks, Don. That was really short and sweet. You brought us back to the time. So, the one of the very important role in the College of ACES is played by the Agriculture Experiment Station. And the next speaker, Dr. Prihodko, I'm sorry, I can never pronounce your name. So Lara is the Associate Director of AES, and, she will sort of summarize the whatever we talked about today. Lara, the floor is yours.
All right. So I was going to just take a step back from all of this to talk about a universal challenge that we've all faced working in digital agriculture, whether we're on the agriculture side or the technology side, and that is that ability to work across those disciplinary aisles. So I'm going to talk a little bit about a new program that we have here at NMSU to help with that. So I know when I first started working in the field, it took a lot of effort for us to talk to our computer science colleagues or our engineering colleagues about what our problems were, and for them to understand what our problems were, and for us to develop a common language about that. And so what a recent program that we're getting started and recently got funded from our National Science Foundation is called the National Traineeship in Artificial Intelligence for Arid Land Agriculture. And what we're doing with that program is we are developing a pathway to put disciplines together so that they don't have to work through all of those barriers that we all had to work with when we first started out. And I know it's taken us I've been working with our computer science faculty with Derek for probably the last 3 years, and even now we still sometimes have challenges in explaining or translating what we need to. So what this new program will do is create cohorts of students who will go through the program together. So they will develop core knowledge in a disciplinary area. So that could be in computer science or artificial intelligence, data science, or core knowledge in agriculture, but that they'll develop a competency in the other. So at the same time that they're going through the program, they're taking classes together. They might be programming classes, they might be agriculture classes. One group will be more in depth on the computer science side, one group will be more in depth on the agriculture side, but they'll be able to converse with each other about what they're learning about, and then they'll be actively engaging with each other in research projects over the course of their degree program. So the idea here is that they'll be leveling their knowledge base together, and then working on these different problem areas in arid land agriculture together. And we're also looking together to put together really diverse groups of students. So in New Mexico, we have a highly diverse community. So we're looking to put together very diverse groups so that we get very different perspectives on agriculture. across the spectrum. And so they'll be doing this to make progress. They'll be addressing some key issues in precision livestock management, in precision agriculture, and also looking more at the genetics and phenotype realm. So we'll be putting together all of these different groups together. And in the end, what we're hoping to do is create a replicatable program that can be then used in other places, other universities, both nationally and internationally, to bridge that gap between different types of practitioners in digital ag. So that's a new program that we have that takes all of these different areas of expertise that we have, put that knowledge together to train the next generation of students. So.
Thanks, Lara. All right, I think this is it from us. We also thank Mario Allegri, who is with us. He is our bridge between New Mexico State University and IACA. And under his leadership, we really look forward to have a lot more collaborations with IACA. So now the floor is open. Any questions for any of the panelists here?
Muchísimas gracias a todo el equipo.
Thank you very much to all the New Mexico State University. Very interesting, all the different viewpoints. And because of time, we can have one question and a very quick, possibly two questions. So if you have any specific question for them or for Luis Adrián Salazar, who spoke before them, who was one of the first in the Fab Lab we met. Any question? Nicolas, please go ahead. I have a question for the university team. My name is Nicolas Andinele. I'm part of GBOT. I want to know if the different lines you work, do they have economic viability? Do you have a certain scheme in the university to mainstream that development for it to end up in the market? Do you have any way to mainstream any of these developments?
So, bottom line is that we are right now not trying to go for patent because most of the times we are using either the IOTA systems or we are using those systems which are freely available, public domain programs and softwares. Even for the robot, the arm and everything that we are getting is all in the public domain. So certainly right now, we are not thinking about patenting any of those things, but certainly economics is a very important aspect here, because one of the biggest challenges of people not using the sensors, at least here in New Mexico, and I'm sure it is true for the many parts of the United States as well as in other countries, the people who are here, cost is a big issue. And right now, just to give you an indication, the robot costs around $25,000. It will be very difficult to convince the growers to spend that much money for one robot. So we are fully aware of that. So the next steps are to bring down the cost of the arm. So most expensive is the arm. And if I give the floor to Derek, I'm sure Derek will tell us that all those buttons and whatever technology you get for monitoring the animals, those are also very expensive. Those has to be brought down considerably. So yes, we are fully aware of it. And one of the future goals are to bring down the cost of the robot, maybe use some of the technologies that Arduino-based technologies that we have developed here locally for soil moisture types of measurements, if we can use those to do something other than that. Derek, will you like to add anything to this?
Just that there is a lot of companies moving into the space of on-animal tracking and on-animal sensors. And so there's a lot of entrepreneurs working on that. They're still expensive, but there may be approaches of maybe not monitoring every single animal in the herd, but using a sentinel animal approach, just monitoring a few. but there are some producers buying it, but cost is still a huge deal. Most of the products are probably just out of reach, but the cost should be coming down as these technologies evolve.
Thanks, Derek. Does that answer your question?
Sí, muchísimas
Oh, yes, thank you very much. And with this, we conclude this first afternoon session. And to those who follow us in social media live, we're going to take a short break. In the meantime, we'll be showing a video and you can all watch it. And when we come back in 15 minutes, we will have the presentation of two startups that, because they won the contest that we present, and these are Agroconsultas and AGROS. And after this, we have a panel with the role of the institute and of development and innovation before digital transformation. So what's the role from a research standpoint? So I invite you to connect and come back in 15 minutes. Thank you very much.
Como todas las grandes historias, la del ICA se construyó con trabajo, tiempo y resultados. El Instituto Interamericano de Cooperación para la Agricultura, IICA, celebra en el 2022 sus primeros 80 años de vida. Cimentada en un historial de impactos en favor del bienestar de las comunidades rurales y el desarrollo agropecuario de las Américas. El cumplimiento de esa misión se apoya en una oferta de cooperación técnica innovadora y de excelencia, siempre en actualización y alineada a las necesidades de sus 34 Estados miembros. Son soluciones que se conciben y se implementan a partir de la acción de una red de expertos distribuidos estratégicamente en 35 oficinas que escuchan, proponen y actúan para ejecutar proyectos que agregan valor, generan arraigo, secuestran carbono, cuidan los suelos, refuerzan la seguridad alimentaria y nutricional, incrementan productividad e ingresos, potencian el comercio y contribuyen a la generación de un círculo virtuoso que jerarquiza la actividad agropecuaria y fortalece la vida rural. Son acciones que apoyan que no habrá un futuro próspero sin agricultura y que la agricultura de un mejor futuro debe ser intensiva en conocimientos, sustentable y socialmente inclusiva. Educativa y sensorial sobre las tecnologías que modernizan el agro, la construcción de la Plaza de la Agricultura de las Américas y la Casa Rural, y el Fab Lab, especializado en innovación tecnológica para reducir la brecha digital rural. Este ICA de puertas abiertas también opera sobre una gran plataforma de gestión del conocimiento sobre agricultura y en una red de alianzas estratégicas que lo vincula a los principales centros de excelencia del mundo y con los que aborda temáticas supranacionales como la degradación de los suelos, la inclusión digital y la promoción de la innovación y el cooperativismo en favor de los agricultores familiares, de las mujeres y de los jóvenes rurales. Como puente para actuar con países, regiones, gobiernos, el sector privado, la academia y la sociedad civil, de modo de avanzar hacia esa nueva ruralidad. El IICA enfatiza en esa oferta de dimensión ambiental, colaborando para incrementar resiliencia y adaptación y contribuir para que la agricultura, los sistemas agroalimentarios y las comunidades rurales se sobrepongan a la vulnerabilidad climática, reduciendo también la emisión de gases de efecto invernadero y aumentando el secuestro de carbono. La conformación de alianzas y la puesta en marcha de programas para trabajar por y para los países pusieron en primer plano la capacidad de articulación del IICA reflejada en el histórico consenso de los países en torno a los 16 mensajes que unificaron la posición de las Américas en la Cumbre de Sistemas Alimentarios de la ONU. Esos mensajes reforzaron el papel irreemplazable de la agricultura y recordaron que los productores agropecuarios y los trabajadores de los sistemas alimentarios son un eslabón imprescindible y central, y que sin producción agropecuaria no hay materias primas para transformar en alimentos. También destacaron a la agricultura como una actividad fundamental para erradicar la pobreza, impulsar el desarrollo rural y proteger el medio ambiente, articulando de todo el continente para resguardar y reforzar la sanidad vegetal y animal. El ICA, en camino a su centenario, también acrecienta día a día su vigencia al cumplir una misión sensible y estratégica: llevar paz y prosperidad a los territorios rurales y contribuir a un mejor futuro para los pueblos de nuestra América, ayudando a que la región consolide su liderazgo como garante de la seguridad alimentaria, nutricional y ambiental del planeta.